So we continue from where we stopped. So the other class, the other parts, we stop at theorem 4. But here we want to go to theorem 5. But before we go to theorem 5, we need to explain some things here. That means theorem 5 is under cyclic quadrilateral. Cyclic what? Quadrilateral. And what is cyclic quadrilateral? A cyclic quadrilateral is a four-sided plane shape. A cyclic quadrilateral is a four-sided plane shape with a circle passing through all the four vertices, that is, all the four corners. So look at this circle here. We have one corner here, another corner, another corner, another corner. That is four corners. Then surrounded by the circle. So circle is surrounding the four corners. So that's about cyclic quadrilateral. Now under theory 5, theory 5 says that the sum of the opposite angles of a cyclic quadrilateral is 180. The sum of opposite segments, opposite cyclic quadrilateral is what? 180. That is, this side plus this side is 180. So this was telling us that angles in opposite segment of a cyclic quadrilateral are supplementary. It's telling us that angles in opposite segments of a cyclic quadrilateral are supplementary. So that is, sum of this and this is what? 180. Now we want to prove that given a circle AXB, AXBY with center O, prove that ASB plus AYB equals to 180. So to prove that ASB plus AYB equals to 180, then we have ASB. Now look at this circle now. We have AXB. Now to get our ASB, will now be half of P. Look up. To get this side, this is the angle at the circumference. Our x is the angle at the circumference. To get this x, that is why we always indicate the x with subscript. So now, to get this x, will now be half of P. Why? Angle at the center. Angle at the center is twice angle at the circumference. Is twice angle at the circumference. So that is AXB is half of P. So the same thing. AYB equals to a half of Q. Because we cannot use this place, we cannot use half of this to be this place because they are in the same segment. Look at it. If you are to divide this circle to two equal parts, P is within Y here. So we can't use half of this to get this, because they are in the same segment. So we can only use half of this to get the other side, to get our x. Now to get our y, now we have be half of q. So what is the reason? Angle at the center is twice angle at the circumference. So are you getting me? So angle at the center is twice angle at the circumference. So if AYB equals to half of Q and ASB equals to half of Q, that means therefore AXB plus AYB equals to half into bracket of P plus Q. We combine them together. That is half times Q will still give us half q, half times p will give us half p. Half times plus q will still give us half q. And we said asb plus ayb will now be equals to half of both of them. So, but p plus q is equals to 360. But p plus q equals to 360. Angle at a point. Angle at a point. Angle at a point. Let me write it very well. Angle at a point. Angle at a point. So can you see P plus Q equal to 360. So that is from here to this place 180. From here to this place is also 180. That is, we have 360. That's why we say P plus Q equals to 360. And if that should be the case, it means that our ASB, our P is our ASB. ASB plus AYB equals to half. You know, P is ASB, Q ASB equals to half of 360. Half of 360. That is, we divide 360 to 2 to get all this. So therefore, AXB equals to AYB equals to 360 divided by 2. 2 here 1, 2 here 180 equals to 180. Equals to 180. Equals to 180. ASB plus AYB equals to 180. So that's the value proof of ASB plus this equals to 180. So that's about theorem 5. So theorem 6. Theorem 6. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. The exterior angle, which is this, our exterior angle is x, of cyclic quadrilateral is equal to the opposite interior angle. This opposite interior angle. That means we are asked to prove that y is equal to x. So to prove that, let's ADC. ADC. I did this angle. Let ADC equals to a degree. So, do you know that A plus Y equals to 180? Why is it that A plus Y equals to 180? It's because opposite angle of cyclic quadrilateral are sum of opposite angle of cyclic quadrilateral from the theorem 5. Sum of this is 180. Sum of them is what? Is 180. So sum of opposite cyclic quadrilateral or lateral. So that is about y a plus y. Now look at this side as well. A plus x. A plus x equals to 180. Y, sum of angles on the straight line. Sum of angles on a straight line, that is a plus x. Now if a plus y equals to 180 and a plus x equals to 180, so since a is common, since a is common, look at this, a plus this equal to this, a plus this is equal to this. So okay, let me make it we are asked to prove that x equal to this. From here I can make, before I write this one, I can make my y the formula y equals to 180 minus a. Then from here also I can say x equals to 180 minus a. Therefore our x, or rather our y, is equals to x degree. So both of them gives us the same thing, which is 180 minus a. So that is about the proof of theorem 6. So in the next part we are going to take examples. Thank you.